How are you doing? Thank you for your interest in the DWA water quality model. In this video, the basic work of setting up an application example is presented. The model is delivered as a setup file. Double-click on it and the setup procedure starts. Here you can get information about the version of the DWA water quality model. With next you can get the selection of the folder in which you want to save the model. At the next step you will be asked in which folder the simulation results should be stored. With click on install, the setup procedure will be finished. Now we come to the first steps. With a double click on the executable program which we have saved in a folder in the setup procedure, we get into the DWA water quality model. Now we want to create a new project. Click on New, and now the structure of the new project has been created. This project is now on the top level. This could be, for example, University Duisburg-Essen, short UDE. On the second level, we can enter a name with which the variant of the project gets a name. For instance, case study number 1. In another video, I will come to the remaining content which can be seen under variants. Under constants, a lot of information is stored in form of numerical values in order to be able to calculate the processes of substance reactions within the water body. In the folder Rivers, we can store rivers or complex river systems. Now we want to import the coordinates of a longitudinal course of a river. Therefore, we click on the button Extras. By pressing the button Import Nodes Wizard, we can load the coordinates of the river course into the model. Here you can load a file in a CSV format. The first column of the file must contain the coordinates for the easting and the second column the coordinates for the northing. The separator which is used in the file to be imported can be set here. At this point of the import you can add longitudinal coordinates manually or delete existing ones. With a click on Next, you can see that the program has calculated a minimum length of the flow from the given coordinates. Usually the river is longer than the direct connections of the coordinate points. Therefore, we enter the correct length, for instance 40 kilometers. Here we also enter the river name, for example, river _1. With the next click, you get internal information, and with Finish, the import is completed. Now you can see that our river number 1, is generated. A click on the small triangle to the left of the river name leads us to 4 more folders: the profiles, regions, sections and notes. In general, you can activate or deactivate subfolders by clicking on the small triangles. For the simulation, it is essential to link the cross-section of the river with the model. We do this by pressing the Profiles button and right-clicking Append a placeholder for the profiles. Left-clicking on the corresponding small triangle shows us the symbol for the cross-section profiles. By clicking on the symbol, we get the possibility to assign a name for the cross-section profiles, for example, CR_River 1. Then we activate the button 1, 2, 3, which stands for the input of numerical values, and change this by right-clicking and selecting Characteristic File. Then we press on Characteristic File and enter a file name. This file name must have the ending .qpf. For example, cr_river1.qpf. The cross-section data of the river must be stored in this file. Now we have entered the longitudinal and the cross-sections of the river into the model. For the required format of the cross-section profiles, please refer to the operating instructions or the video DWA Water Quality Model Structures and Formats. Now we skip the next two folders and go directly to the notes. A click on the corresponding triangle shows us several blue circular symbols, so-called support points. These are imported notes for the description of the longitudinal water course. A click on a node shows us the corresponding coordinates. Now we convert the lowest support point into the headwater or the source of the river. With a click on this button and a right click, we get to the option Change Type. With Start Cross-Section Runoff, we define the headwater. Now we can override the default value with a realistic value, for instance 1 cubic meter per second. Finally, we have to determine the end kilometer of the simulation reach. This corresponds to the length of the river, in our example 40 km. Now we click on the uppermost support point, and with right click and change type, we have the possibility to select the option and cross-section free outflow. The corresponding river kilometer is 0 and thus corresponds to the default value. Now, at the latest, we should save our project. All information for a minimal example is entered in the model. That means we can start the simulation. To do this, we press the button Simulation and Run. Now, have fun with the simulation. Goodbye.